Once again, we're back with everybody, and we are still tracking the properties of determinant, is it right? So in between the time, I'm just doing some more problems, and that could be more helpful for you because yesterday also in LA13, I think maybe is it right? I got some more problem, and that could be more helpful because it was a specific shortcut. It's a shortcut what we did, and that could be more and more easier for you if you just follow the same way. Okay, so now listen here. How I'm gonna have a small how we talk about determinant property. Now listen here. For any square matrix means what the dimension should be signed. That means a row and column should have the same dimension. That means for there comes a 2 row, that should be 2 columns. That's right. This is the Albert square matrix. Once again, just recollect. And now look at here. And the first one, I have the idempotent matrix. Idempotent means if I just have any natural number over this matrix, that means what if I take a matrix of A, 2 is a natural number. That means what I can have A cube, A power 4, anything, no problem with this one. So if I have any natural number, that means in other case for any natural number over the index, that means it's called, this represents the index of a matrix. That means what we say power etc. This comes the index. A square that's equal to A. If this is a condition and that square matrix is said to be idempotent. You understand it right? A square is equal to A. That means for any matrix, if that comes a squaring of the matrix, and if the resultant gives the same matrix, means what that matrix is called the idempotent matrix, and that one should be a square matrix, and that index should be a natural number. It's not going to be some irrational or irrational. It's not like that. It should be a natural number. Okay, that means natural. Now look at here. Let's have a small example. There comes a I get some small. That means for the 2 dimension. So 1 0 0 0. And if I just square it, so a square is equal to I into A. Suppose if I just make a multiplication of these two and finally resultant, I get the same matrix as that of A. So it should be equal to A. So idempotent means if I just multiply 2 matrices of the same, that means for same matrices, the 2 times or 3 times or 4 times or any times where just multiply, resultant is the same primary matrix, and that should be idempotent matrix. And now we see about another matrix. Just wait, let's take a test through and I'll come back immediately. I got it. Okay, now listen here. I have another matrix. Now what I do, I wrap off this everything. Okay, now I wrap off this, and I wrap off this statement also. In any case, I wrap off once again, and I just do once again this also. No problem about this one. Now I got for about second one is about involutory matrix, and this also comes as a square matrix. Okay, for an involutory matrix, the A square value should be equal to I. If I do any number of having index over matrix, and the resultant matrix should be identity matrix. Okay, for my convenience, I take the A matrix as I is equal to -1 0 0 1. You can have also anything, any matrix, no problem, because this could be a standard matrix. Okay, you don't think about I'm just copying from anywhere, no problem with this one. This is a standard matrix given by more scientists, more mathematicians. So what I do, if I go for squaring, that means what? That means I'm going for A square, which represents A into I, which I equal to -1 0 and 0 1. And once again, I think this is clear. I think it's under the view, is it right? Okay, suppose if it's not view, means you just do the comments. And once again, -1 0 0 1. If you do the multiply everything, and finally the resultant gives 1 0 0 1, which will be a identity matrix, right? I matrix of 2. So 2 or 3, no problem, because this is a 2 cross 2 matrix. So that's represented by I2. Okay, so that means what? For any square matrix, if the index of any matrix of any natural number, if that comes a resultant of identity, then that matrix, the square matrix, is called involutory matrix. Okay, because these definitions are more and more important for any competitive exams, including GATE and including any type of transfer also. That's more important. Okay, so please have a small look about this one. That is more and more important. And now afterwards, I'm going to have one more matrix. Okay, because that's also another property. Please have a small check. I'll just wait for some small minute. Okay, have a small check. You got me right, no problem. Okay, now I wrap up everything. And we gotta see about one more thing, that is called what? nilpotent matrix. So here I wrap up this one, and I have a small thing is called a third one. The first one is, what's the first one? Idempotent matrix and involutory matrix, and then finally this is about nilpotent matrix. I hope all these words are clear for your vision, right? If anything is gonna be diminish or if anything is not clearly visible, you drop the comments in the comment section of the video, okay? Please don't have any other hesitation. Don't problem with this one. Do the things and get a feedback to me, okay? So for nilpotent matrix, for a matrix of any natural number, if there comes a zero means what? Zero matrix, all elements are zero, okay? So this is called zero. That means, in other words, it's a nilpotent matrix. Now I hope you understand this right. For any square matrix of any, that means index, it is straight index, okay? Don't say it's a square or power or anything, okay? It's not a power. Index for a power 0 is equal to 0. That means a zero matrix is there to be a nilpotent matrix. So what I say means you just recollect once again back to back, because I'll be back if you lost. One more thing also should be valuable, okay? You gotta understand it right? Anything more extra needed? Okay, no problem. So what I do, I make a very small proof. So I is equal to, you take my own convenient matrix, I may take no problem, because you take your own matrix. It can be a 2 cross 2, 3 cross 3, can be any type of any order matrix. So 0, 1, 0, 0. Okay, for my convenience I take a square, because I go by the simple way of matrix. That could be more easier for the viewers, okay? I square is equal to, so a into a, which will be equal to 0, 1, 0, 0 as multiplied by 0, 1, 0, 0. And if you do the matrix multiplication, if you just know about the matrix multiplication, just look at the previous video. You may get a more help, you may get a more guidance about this one. You don't say about the matrix multiplication, not possible. This one, you look at the back to the previous videos, it could be more helpful for you, okay? If you do the multiply, what I will get it 0, 0, 0, 0, and this is called zero matrix, and the matrix we're just getting have the index of any order. So this is called what? Index of 2. For the index of 2, for a matrix, that means if I just go for 2, means if I a square, that means I into a. If the resultant is zero matrix, now what is kill what? And that is a nilpotent matrix. So should I just find about three things? What are three things means? The first one, idempotent matrix. That means what? A power anything is equal to I. The involutory matrix, and a power anything is equal to identity I. And finally nilpotent matrix, a power anything is equal to 0. And this is about the old shortcut, because it could be more helpful for you, because you don't think about the simple basic, because in my upcoming successive classes it could be more and more, so you also succeed me. That could be more helpful for you, because I'm not taking only the basics. If I take only basics, I'm going to take a small clue, a small shortcut to be trespassing to the longer extent. So I may say, I don't know very clearly, I may say you will be getting a more toughest problem, and if you just learn about more basics here, the shortcuts will help you, and that shortcuts will be applied for the any type of competitive exams for your case, okay? Be brave always, stand strong. Thank you very much.